Hello, my name is Mihai Pupaza. I am in the final year of my mechatronics degree and this is my graduation thesis. A system used for assembling small batches of PCBs. It costs just under 1000 euros. It consists of a 3D printer, a pick and place and a hot plate. The whole system makes your PCBs look from this to this, something that is ready to be shipped. The system is useful for startups, universities, makerspaces and hobbyists like me. Now let's dive into the process. A new PCB assembly order comes in. This PCB needs to be populated. First I will design the stencil. I start with a 3D model and simply extrude the pads. The thickness of the stencil is 0.2 mm. I have printed this on my modified Ender 3 with a 0.3 nozzle, but a diameter of 0.2 mm on the nozzle would be even better. Also, a bed adhesion substance like hairspray or glue stick helps a lot. This is the final result printed out of PETG. A metal sheet stencil from China costs 30 euros including shipping to Europe. A printed one costs basically nothing. It weighs a couple of grams and is printed in 5 minutes. While this is not perfect and it requires a bit of detailing, it works great considering the cost and the speed. I can now take the PCB with the solder paste applied and put it on the pick and place. The machine now assembles the PCB. It picks up each component with the vacuum nozzle tips, hovers them over the bottom camera and calculates the offset from the center of the nozzle to the center of the component and places them on the PCB with the positional and rotational corrections applied. All the components have been placed. Now I can melt the solder paste on the hot plate and after 4 minutes the PCB is fully functional. Now that you have seen the whole process, let's talk about the heart of this system, the pick and place machine. As you can see, those components are really tiny. In fact, they are 0.6, 0.3s. In order to place those components reliably, a solid and robust and repeatable motion system is needed. The chassis is a modified 3D printer because it was the easiest and the cheapest option. What I liked about this printer was its simple construction. The upper plate is made out of laser cut aluminum and then the rest of the chassis is made out of 2020 extrusions. The motion system is Core XY, so theoretically, because both of the X and Y motors are stationary, greater accelerations can be achieved. And the chassis uses linear rails because at those component sizes they are the only option to get reliable picking and placing. The head is completely designed by me. It is 3D printed and it houses the two nozzles, each with a different size for different components, and the two nozzles are placed on the two NEMA 8 stepper motors with hollow shafts for the vacuum. The Z motor is here behind and the Z is shared between the nozzles. When one lowers, the other one goes down. I have also used here linear rails for precision and reliability. Also, behind the head is the top camera that is used for calibration and for finding the fiducials. Now, for any vision system, the lighting is crucial. It needs to be bright, accurate, and in this case, circular. Thus, I have used a ring of NeoPixels. I managed without a diffuser and I've managed with those RGB pixels. They are not great, but the vision works okay. The whole system is powered by a 12 volt 5 amps power supply and the motherboard runs Marlin, a custom compiled version of Marlin, on a maker base Robin Nano V1.2. The Marlin part was a bit more complicated because Marlin is built primarily for systems with extruders. This obviously has none of them, but has two rotation axes instead. Thankfully, the documentation was great, and after a few hours of struggling around, it worked great. The feeders are called blinds feeders. The author is the user Markmaker from GitHub. What he has done here is just great. The design is parametric and can be customized in OpenSCAD with a few lines of code. These small components have the nasty tendency to jump around if not handled with care. The blinds keep them in place, making the preparation of the job much easier. Thanks, Mr. Markmaker. Of course, none of this would be possible without OpenPnP and the power of open source. What the developers have managed to put together for more than 10 years now is just stunning. The complexity of the code to make a pick and place function and to calibrate the way it does is just beyond my understanding. Huge thanks to them. So, this is my journey in building a functioning pick and place. Most of the design decisions that I've made are optimized for simplicity and for cost. The machine is not the fastest, the stencil is not the cleanest, but it gets 80% of the job done with 20% of the effort and money. I hope that you enjoyed the video, and I hope that it inspires you to build something like this with OpenPnP. And thanks for watching. Bye bye.